Okay, Honors Math 3, Unit 2, Objective 5 notes, inequalities with higher powers of x. Okay, so there's a certain process we're going to go through as we're doing these. We want to get 0 on one side of the inequality. We want to factor and find the zeros. They usually factor. I won't promise that they all factor. The zeros, the roots. We're going to use a number line as we're doing this. So we're going to plot the zeros on the number line. And we will test the intervals for whether they are positive or negative. Okay, and when we have whatever the inequality is, and if we have greater than 0, then obviously that is indicating that we are looking for the positives. And if we have whatever the inequality is less than 0, then that's indicating we will be looking for the negatives. If they have the or equal sign, so if it's less than or equal to or greater than or equal to, then that is a situation where we include the zeros. And if it doesn't have the or equal sign, then we are not including the zeros. Okay, so we need to see some example problems. And so here we go. Here's our first example. Okay, so x squared minus 9x greater than 36. So as we already mentioned, we do want to get 0 on one side. So where's the highest power of x? It's right there. It's x squared. It's positive. And so it's nice when the highest power of x is positive. So let's bring everything to the left-hand side. X squared minus 9x minus 36 is greater than 0. And most of these, almost all these factor. So, sometimes we do have to use some other methods, quadratic formula, or perhaps completing the square to get the zeros. Anyway, factor the ones that factor. And so x minus 12 times x plus 3 is how it factors. And the zeros are 12 and negative 3. Okay, plot those on a number line. Make sure the smallest one is on the left and the bigger one is on the right. In this case, we cannot touch the zeros because it doesn't have the equal part, the or equal part, so hollow dot. Okay, we're now going to test the interval by plugging in numbers. Now, effectively, once we get 0 on the one side, we're thinking of this, the x squared minus 9x minus 36 as a function. So we could call that f of x. So we're going to plug in something to the left of negative 3. How about negative 4? Between negative 3 and 12, how about 0? And something to the right of 12. So how about 13? Okay, so if I input a negative 4, and I'm going to plug it into the factored form. I've got negative 16 times negative 1, which is positive 16, but really we're just interested in positive or negative. So out here to the left, no matter what we plug in, we would get positive. If I input 0, 0 is really nice, plugs in very nicely. So 0 minus 12, negative 12, 0 plus 3, positive 3, so negative. And if I input a 13, we get positive 1 times positive 16, which is positive overall. Now, we are looking for greater than 0, and it is greater than 0 where we have positives. So we want everything out here to the left. We want everything out here to the right. And so our solution set for this problem is from negative infinity to negative 3 union 12 to infinity. Okay, let's try second problem here. 10 plus 3x greater than or equal to x squared. Okay, highest power of x is on the right-hand side this time, and it's positive. So let's move everything to that side. So 0 is greater than or equal to x squared minus 3x minus 10. And now we can factor it and deal with it this way, but I think it's usually easier if we have the x's over on the left. Of course, you say, you know, we just moved everything to the right. Well, let's have them change sides. We don't need to change the signs or anything. Let's just have them change signs. Let's not put the sign in yet. Now, alligator's eating the 0, so have the alligator eat the 0, and it's the same problem. Okay, so we can get the critical numbers, the zeros, x minus 5, x plus 2. So zeros are 5 and negative 2. And a number line, negative 2 on the left. Now this time we can equal 0, so the zeros are included. Okay, and here is our function. And so if we test maybe negative 3 to the left of negative 2, let's do 0 again. 0 is a very nice one to plug in. And also let's input a 6. Okay, so if I input a negative 3, I get, no, we don't really need to know the actual number when we're using the factored form. We just need to know if it's positive or negative. So negative 3 minus 5 is negative 8, so it's negative. Negative 3 plus 2 is negative 1, so negative, and negative times negative is positive. Okay, if we input a 0, we've got negative times positive, which is negative. And if we input the 6, we get positive times positive, which is positive. Now, we are looking for values of x that will give us less than or equal to the 0. Now, the equal 0 part are the zeros, negative 2 and 5, but less than, that would be the negatives, and the negatives then are between negative 2 and 5. And so that would be the closed interval from negative 2 to 5. Okay, so moving on. Problem number 3. We actually have 3a and 3b. So x squared plus 4 greater than 0. Now, it does not factor. We could get critical numbers out of there. If you think about it, we'd actually get imaginary numbers to get zeros out of there. Now, typically, the imaginary numbers, it's telling us it's a special case of some sort. Well, if we think about it a little bit more here, what's the smallest x squared we'll ever get? Well, whatever I plug in for x squared, the smallest it ever gets is 0. Because if I plug in a 0, it's 0 squared, but if I plug in any other number, it gets bigger once you square it. So the smallest is 0 plus 4. This is always going to be positive. And we're looking for greater than 0. So no matter what we plug in, it's going to work. So the solution set for this particular problem is any real number. So all reals is the solution set for this one. Now, on the other hand, what if we had x squared plus 4 is less than 0? Same situation, x squared plus 4 is going to be always positive. Of course, this time, instead of looking for positive, we're looking for negatives. Well, if this is always positive and you're looking for negatives, you're just out of luck. And so there is no value of x that would cause the left-hand side to become less than 0. And so therefore, there is no solution for this particular problem. Now, what if instead of, let's go back to the first one here. What if instead of greater than 0, what if it had been greater than or equal to 0? Does that change our solution in any way? Well, this side is always positive, and even though you can't ever equal 0, we're certainly not going to take away any value of x, because all we're looking for is values of x that will make this left side greater than or equal to 0. So even though we can never equal 0, we will always be greater than 0. So there's still an infinite number of solutions that are greater than 0. So no change to our solution set if we have the or equal part. What if we had the or equal part over here on this side? We can still never equal 0. So it's not going to change our solution of no solution here either. Okay, at this point, I'm going to do a couple of sample problems. Well, not sample problems, but actual couple problems from the assignment with you. I thought maybe we'd go ahead and do problem number 8 together. X squared minus 6x minus 3 greater than or equal to 0. Okay, so we've already got 0 on one side, and we look to try to factor it, and what do you know? This one does not factor. I did mention that they don't always factor. Well, since it's x squared, it's just a quadratic. Can't just say, well, there's no zeros. I mean, there are a couple zeros in there. We just have to be able to find them. Since it doesn't factor, we can either do this by the quadratic formula or by completing the square. Now, since the coefficient of the x squared term is 1 and the middle term coefficient is an even number, completing the square is actually very nice on this one. So let's go ahead and do that. Now, we're just after the zeros, and so I know it's an inequality, but since we're just after the zeros, I'm going to do an equal sign here instead, because all we're trying to get right now are the zeros of this function here on the left-hand side. So I'm moving the negative 3 to the other side, and half the middle term coefficient is negative 3, squared is 9, and so we add 9 to the other side to keep the equation in balance. And of course, the left-hand side factors as x minus 3 times x minus 3. In other words, x minus 3 quantity squared. That's why it's called completing the square. And we have 12 on the other side. Okay, so we take the square root of both sides. And of course, the left-hand side is the absolute value of x minus 3. And the right-hand side is the absolute value of 2 root 3. Of course, the absolute value of 2 root 3 is 2 root 3. Now, this equation will be satisfied if the inside, x minus 3, is equal to either plus positive 2 root 3 or negative 2 root 3. So we're going to set the inside of the absolute value, x minus 3, equal to both of those possibilities. So x minus 3 equals both of the possibilities that will satisfy the equation. And we can finish solving for x by getting 3 plus or minus 2 root 3. Now, those are just the zeros of the function. We can go ahead and do our number line. Which one goes on the left? Well, the smaller one. So 3 minus 2 root 3 is on the left. And 3 plus 2 root 3 is on the right. Now go back up here and take a look. The inequality says greater than or equal to 0, so we can touch them. Solid dots. We're going to have to test the intervals, and so it's handy for us to know at least approximately what this value is. Now, 2 root 3 is root 12. Root 12 is, it's about 3.5. So 3 minus 3.5, so this is about negative 0.5. And 3 plus root 12, so that's about 6.5. Okay, so plugging in numbers. We don't have a factored form here, so it's a little bit more challenging. So if I did f of negative 1, f of 0, and f of, let's say, 7. Since it's not factored form up here, we actually have to know what the numerical values are here. So negative 1 squared is 1. Negative 6 times negative 1 is positive 6. Minus 3 is positive 4, but it is positive. Okay. If I input a 0, 0 is nice. So input a 0, we get negative 3, which is negative. And if we input a 7, I get 49, and minus 42, and minus 3, which is positive 4. Positive. Okay, so we are looking for where this function on the left is greater than or equal to 0. The equal part are the zeros. Greater than 0, or where it's positive. So we want out here to the left and out here to the right. And so our final solution, using interval notation, negative infinity to 3 minus 2 root 3 union 3 plus 2 root 3 to infinity. Okay, so they don't always factor, but we can still get those zeros, the critical numbers there. And let's try one more. And let's make it number 11. Okay, so number 11, we have 13x cubed plus 2x to the 4th less than 24x squared. Okay, now at this point, I know that many of you are probably looking at it and you're just going, oh, there's a GCF of x squared. Let's just divide everything by x squared. No, you are not allowed to divide by a variable. You are changing the problem, and it would change the answer. So make sure that you are not doing that. Now, let's look for the highest power of x. Highest power of x is the x to the 4th. It's positive already. It's here on the left side. So let's move everything to the left and get it in descending powers of x. So 2x to the fourth plus 13x to the third minus 24x squared is less than 0. Okay, now on these higher powers of x, it is going to factor. So factor, there is a GCF of x squared. And of course, we need to factor the inside as well. So go ahead and take care of that. We get 2x and x, and let's see, factors of 24. How about 4 and 6? Well, that would give us a GCF of 2, and we already pulled out the GCF. The GCF on the inside is just 1, so it couldn't be 4 and 6. How about 3 and 8? Could I put the 8 there with the 2x? No, there'd be a GCF of 2. So we better put the 8 over there and the 3 right there. Let's try that. Okay, 16x, 3x. Yes, we can get a 13x if the 16x is positive and the 3x is negative, and then negative 3 times 8 is negative 24, just like we want it to be. So it's now factored. We have zeros of 0, 3 halves, and negative 8. Okay, so number line, if you have more than 2 zeros, just make sure that it's in order, smallest ones on the left and biggest ones on the right. So negative 8, 0, 3 halves. Can we touch them? No, there's no or equal part, so no touching them. How many different intervals do we need to test? We need to test 4 intervals, something to the left of negative 8, something between negative 8 and 0, something between 0 and 3 halves, and something to the right of 3 halves. Now at this point, I know, many of you are saying, well, just find one of them and then just alternate the signs. Don't count on that because it doesn't always work. We will get to some shortcuts eventually, but right now you just got to plug in numbers. So here's our function, and luckily there's a factored form there. So if we plugged in maybe a negative 9, unfortunately we can't plug in 0 this time because it's one of the zeros, but how about negative 1? How about positive 1? And how about positive 2? Okay, so if we input a negative 9, negative 9 squared is positive 81. Okay, 2 times negative 9 minus 3, that's negative. Negative 9 plus 8, that's negative. And so overall, we got positive. Okay, if we input a negative 1, if I square it, is positive. And 2 times negative 1 minus 3 is negative. And negative 1 plus 8 is positive. And so I'm sure that some of you are saying, look, it's alternating. Okay, well, let's just work it out. So if we input a 1, I get 1 squared is positive. 2 times 1 is 2, minus 3 is negative. And 1 plus 8 is positive, and we get negative. Oh, look, the signs didn't alternate right there. Let's plug in a 2. 2 squared is 4, it is positive. 2 times 2 is 4, minus 3 is 1, which is positive. And 2 plus 8 is positive, and overall that is positive. Okay. Now, we are looking for where this function is less than 0, so we're looking for the negatives. The negatives are here in the middle. It does take 2 intervals because 0 is not included, so the solution set is negative 8 to 0 union 0 to 3 halves. Okay, so good luck on the rest of your assignment. I'm not doing any samples of the problem solving thing. You guys need to reason your way through those and go ahead and work those out.